So the next aspect of rational functions that we definitely want to take advantage of right here are something called asymptotes. An asymptote is, generally speaking, a line, although it could be some other curve, that limits the function somehow. And a vertical asymptote is the most basic aspect of rational functions that we know. A vertical asymptote is a line of the form x equals a if the behavior of the function near that line is such that as x gets close to it from the left or the right, the function itself tends to positive infinity. So to show you this, I've gotten an example right here. Y equals x plus 1 over x minus 2. One of the first things we have to recognize about rational functions is that our function f of x, before we can find any vertical asymptotes, must be completely reduced. So even before we start off finding vertical asymptotes, we want to make sure that there are no common factors in the numerator and denominator of the fraction first. So even before we do anything else, f of x is simplified completely. Now, in this case, our function y equals x plus 1 over x minus 2 is already completely simplified. There is no other values in the numerator and denominator, and so we can find the vertical asymptote very easily. In this case, we know that the domain is found at x equals 2, right? X equals 2 is the vertical asymptote. Well, is the vertical asymptote line, I should say, because it is a line, and shown here in this dashed line, dashed form, right here, represents a limiting value for the function, right? We know that the domain of this function is the set of all x such that x is not equal to 2. But since there are no other common factors, it also acts as our vertical asymptote. So what is the behavior right here? Well, you can see visually what's going on. It looks to me that as we get values of x that get closer and closer to 2 from either the left or the right-hand side of 2, we see what's happening. As x gets closer to 2 from the right-hand side, the value of f of x goes towards positive infinity. And visually speaking, as x gets close to 2 from the left, in this case, y tends towards negative infinity. So how do we figure that out? Well, one way of dealing with it is just to just check out some values and see what's going to happen. So let's pick some values of x that get close to 2 and just see what's going to happen. Let's start with what's pretty close to 2. How about 2.5? Let's see what's going to happen. At 2.5, if I put in 2.5 into my function, I'm going to get 2.5 divided by 0.5, right? 2.5 divided by 5, when I substitute it in, 2.5 plus 1 over 2.5 minus 2. 2.5 divided by 0.5 is going to be y equals 5. Well, we can kind of see that, right? Right here, that would be this point. If we put in a number that's a little bit closer, let's say 2.1, what's going to happen? Well, it's going to be 2.1 plus 1, so that's 3.1, divided by 2.1 minus 2, that's 2.1, so I can work that out right here. If I've got 2.1 plus 1 divided by 2.1 minus 2, that's like saying 3.1 divided by 0.1. In fact, that's a 0.1. I'm going to get 31. Let's get a little bit closer. Let's try 2.01 just to see what's going to happen. 2.01, if we put that in, that's going to give us 3.01 divided by 0.01, which gives us 301. In fact, as we get closer and closer to 2 itself, which is undefined, what's happening is that the y values are tending towards bigger and bigger positive numbers. In other words, it's going towards positive infinity. Now, if we were to try from the other side, let's say from 1.5, and get closer to 2, what would happen? Well, I'll just show you one or two more steps right here. If I did 1.5 plus 1 divided by 1.5 minus 2, right? If you think about the way that's going to work, that's 2.5 divided by negative 0.5, which is going to be negative 5. And if I went to 1.9, right? 1.9 plus 1 divided by 1.9 minus 2 is the same thing as saying 2.9 divided by negative 0.1, which is 29. Negative 29, pardon me. In fact, it turns out that if I pick out numbers that are closer and closer to 2 from the left, negative 209 here, this value right here, as we get closer and closer to 2, is tending towards negative infinity. And so we see that the behavior of this graph is just what we said it was. This is the behavior of a vertical asymptote. Now, we don't need to do this every single time. This is a good illustration. Visually, this is in fact what's happening. And we can get this kind of behavior either to the left or right of the vertical asymptote every time we try it. Now, there is something called a horizontal asymptote, which is slightly different. In a horizontal asymptote, the graph will in fact be defined, but this time we want the values of x to increase towards infinity or negative infinity. So a horizontal asymptote isn't dictated by the values of the denominator, the domain, but they are dictated by what happens as x gets large. So what would be the behavior here? Well, we could actually see from the graph itself what's happening. It looks like as x tends towards positive infinity, the y value is going to get closer and closer to this line y equals 1. And as x tends towards negative infinity, the graph will get closer and closer to the line y equals 1, this time from underneath. So what does that mean to us? Well, in this case, we're saying that it looks like our horizontal asymptote is the line y equals 1. Now, we can actually verify that behavior by, again, using values of x and just substituting them in to see what's going to happen when y gets larger and larger. Let's just pick some large values of x, let's say going off to the right. If we put in 10, we're going to get 11/8. If we put in 100, we're going to get 101 over, let's see, 100, that's 98, right? If we put in 1,000, we get 1,001 over 908. As these numbers get larger and larger for x, these values approach positive 1. And the same kind of thing is going to happen as we go off to the left-hand side. Putting in negative 10 is going to give us, let's see, negative 10 would be negative 9 over negative 10 minus 2, negative 12. So that's positive 9/12, which is 3/4. Putting in negative 100 is going to give us a larger and larger value, but still not greater than 1, because it would be negative 100 plus 1, so that's negative 99 over negative 100 minus 2, which is negative 98. So 99/98. If we go negative 1,000, we're going to find our y value is negative, let's see, 999 divided by negative 998, right? Very, very close to 1. So what's happening is that 990, I'm getting those backwards down there. Bear with me, but they're still going to be fairly close to 1 here, only this time from less than 1. So if I were to go back, let me see, let's just do this. Negative 99 over negative 102. There we go. That's a little bit better. 999 for 1000 divided by 1002, right? All of these values get close to 1 again. This time from underneath. So what's happening is that in the horizontal asymptote, they describe the behavior to the far left and far right of the graph, not in the middle. Okay, so that is vertical and horizontal asymptotes. More in the next video.